All right, let's talk about a piece of technology that's, well, it's both a 60-year-old relic and the mission-critical engine that pretty much runs our entire modern world. Sounds kind of crazy, right? Let's dive in. So let me kick things off with a question for you. Think about the last time you went to an ATM or just swiped your credit card at a store. What single programming language do you think is behind, let's say 95% of those ATM swipes and about 80% of all in-person transactions? Go ahead, take a guess. I'll give you a hint. It's not Python. It's not Java. Nope, not C++ either. It's something else entirely. The answer is COBOL. Yep, COBOL. A language that was literally born in the 1950s is still, to this day, the absolute bedrock of global finance. So in this explainer, we're going to unpack exactly what it is, where it's hiding in plain sight, and why, trust me on this, it is anything but a dead language. Okay, so let's get right into it. What is COBOL, really? To understand its incredible staying power, we have to go all the way back to the beginning and look at the very specific problem it was designed to solve. Honestly, the name kind of gives the whole game away. Common, business-oriented language. See, back then, most programming languages were for scientists and academics doing super complex math. COBOL was different. It was created for one reason, and one reason only, to solve practical, real-world business problems. We're talking managing massive amounts of data, handling transactions, and basically running the administrative systems for huge organizations. And that original purpose, being the language of business, is exactly why it's still so dominant today. I mean, its footprint in our modern world is, well, it's pretty staggering when you really look at it. Get this. COBOL systems are responsible for processing over $3 trillion in commerce every single day. And that's not some old legacy number. That is happening right now as we speak. It is the quiet, reliable workhorse of the entire global economy. Now, what's really fascinating is where all that money is flowing. Banking is the giant, of course, no surprise there, making up almost half of all COBOL use. But just look at the other sectors: government agencies, massive insurance companies, airlines. These are all industries where reliability and stability aren't just nice-to-haves. They are absolutely non-negotiable. So the crucial point here is that this isn't some abstract, techie concept. When you book a flight, or you file an insurance claim, or even just check your bank account, you are almost certainly interacting with a COBOL program. It's running quietly on a mainframe, a giant, powerful computer, somewhere in the world. It is the invisible infrastructure of your daily life. Okay, for all you developers watching, I know what you're thinking. Fine, but what does this code actually look like? And yeah, it's definitely different from what you're used to, but it has a very, very rigid and intentional structure. Every single COBOL program, no exceptions, is broken down into these 4 mandatory parts, or divisions. Think of it like a formal report. First, you have the identification division. That's just the basic metadata. Then the environment division, which tells the program what kind of computer it's running on. Third, and this is a big one, the data division, where you have to predefine every single piece of data you're going to use. And finally, the procedure division. That's where the actual work gets done. And this slide right here perfectly illustrates one of COBOL's most famous traits. It is verbose. Just look at the comparison with Python. To define a customer's name in COBOL, you need this formal declaration specifying its exact length. For an account balance, you have to spell out the exact number of digits before and after the decimal. But you know what? This was completely by design. The whole point was to create code that was almost self-documenting, super clear, readable, and unambiguous, prioritizing stability over everything else. Another core concept you gotta know is batch processing. While so many modern apps are all about real-time, instant updates, COBOL excels at the opposite. It's designed to collect thousands, sometimes millions, of transactions all day long, like all of a bank's check clearings, and then process them all at once in one massive, efficient batch, usually in the middle of the night. It's a totally different way of thinking, built for a different scale of data. Now, because it's so old and it works so differently, a ton of myths have popped up around COBOL over the years. So for our final section, let's do a little myth busting. And this is the big one. You hear it all the time. People just assume that because something is old, it must be obsolete, right? COBOL is dead. But the reality is, well, it's a little different. There are over 220 billion lines of active COBOL code in the world today. Billion with a B. And you might ask, why not just replace it? Well, imagine the astronomical cost, and more importantly, the immense risk of trying to rewrite the core financial logic that our entire economy runs on. For these systems, if it's not broken, you do not fix it. And it's not just running on old hardware, it's a vital part of modern, evolving, super powerful mainframe computers. So, why would a modern developer even think about learning this? The answer is just simple economics. There is a massive demand for skilled COBOL programmers to maintain and modernize these systems that can't be replaced. This means incredible job security, excellent pay, and a real chance to work on the invisible engines that power our world. It's a classic case of very high demand and very low supply. So, we'll end with this thought. In a world that is obsessed with a new and shiny, could the absolute smartest career move be to master the 60-year-old language that simply refuses to quit? That's COBOL, the invisible engine all around us. Thanks for joining this explainer.